All right, this lesson is on mole conversions, and it's only part 1 of mole conversions. We'll do part 2 on a following day. But yesterday we just learned what a mole is. We also learned what molar mass is. What we're going to have to do is be able to convert back and forth between moles and grams when we're referring to quantities of different substances that we might use in an experiment. So we've done this before. We've used conversion factors to convert quantities from different units to one another. And a conversion factor is just a statement of two quantities that are equal to each other or equivalent to each other. So for example, 1 minute is equal to 60 seconds. That's a conversion factor. Knowing that 12 inches is equal to 1 foot is also a conversion factor. And knowing that 1 mole of hydrogen is the same thing as 1.008 grams of hydrogen is a conversion factor. So as long as we know our molar mass, we know different conversion factors for different elements. So let's do this first example together. Let's say that Miss Malmos requires 3 moles of lithium for a lab. If she wanted to collect 3 moles of lithium, how much lithium would she weigh on the balance? So what we're going to have to do is figure out first our conversion factor. Now the conversion factor that we're going to want to use is molar mass. So I need to look for lithium on the periodic table and find its molar mass. So I'm going to open up my digital periodic table. Yes, I have one. There's an app for everything. Got several periodic tables. Well, let's open this one. Lithium is element number 3. And it has an atomic weight of 6.94. So what that means is lithium's molar mass is 6.94 grams per mole. In other words, 1 mole of lithium is equal to 6.94 grams. That's how much it would weigh. So if I wanted to weigh 3 moles of lithium, you might have guessed I'm going to have to multiply my mass of lithium, my molar mass of lithium, by 3. Now, I'm going to show you guys how to do this with dimensional analysis so that you've got 2 ways of solving this. You can do it more intuitively, the way we've kind of been problem solving this unit, or if you're not sure where to go, you can always rely on canceling out units. So if I wanted to convert 3 moles of lithium into mass, I would just multiply 3 moles of lithium by a fraction. And my conversion factor is going to help me fill in this fraction. So if I wanted moles to cancel out, I would put moles in the denominator. And since I'm trying to get to grams, I would put grams in the numerator. Now my conversion factor tells me that 1 mole of lithium is the same thing as 6.94 grams. So these units cross-cancel, and I end up doing the same calculation that I might have thought of doing before setting up dimensional analysis. So 3 times 6.94. Let's pull out my calculator and find out what that is. 3 times 6.94 gets me 20.82 grams. So this is the mass that Miss Malmos, myself, would have to weigh of lithium to get 3 moles of lithium for my lab. So whether you're thinking of doing it intuitively or you're wanting to set it up with dimensional analysis, regardless, you should end up typing the same thing in your calculator and getting the same exact answer. So let's do another example together. So a standard sheet of aluminum foil has a mass of 9 grams. How many moles of aluminum atoms is in a sheet? So once again, I'm going to start off by figuring out what's my conversion factor, which in other words means what's my molar mass of aluminum. So I'm going to look for aluminum on the periodic table. Aluminum is the 13th element, Al. Its atomic weight is 26.982. So that means that its molar mass is 26.982 grams per mole, which means that 1 mole of aluminum is equal to 26.982 grams. Now you might be thinking of intuitively how to do this, but it's not very easy numbers to work with. We know that we've got 9 grams, and 9 grams is less, a lot less than this 26.982. So trying to do this in our heads might be a little bit more challenging than maybe the previous problem, which is where dimensional analysis is going to be really helpful. So if I could set this up by multiplying 9 grams by a fraction and getting my grams to cancel out so that I'm left with moles, that would make this a lot easier. So according to my conversion factor, 1 mole of aluminum is equal to 26.982 grams. So my grams are going to cancel, and when I multiply across, in the numerator I'm going to have 9 times 1, which is just 9. And in the denominator, I'm going to have 26.982. And whatever answer this simplifies to, that's going to be my number of moles of aluminum. So I just need to plug 9 divided by 26.982 into my calculator. So 9 divided by 26.982 gets me a mass of 0.3, or not a mass, it gets me moles, 0.3335570, blah, 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 blah. It's a lot of digits. So I'm just going to round it to the hundredths place. So 0.33 moles. And if I think about my answer, this makes sense. 9 is less than half of my molar mass. So it follows that 9 grams should be less than half of a mole of aluminum. So my answer of 0.33 moles of aluminum actually does make sense. And if I wanted to do this more intuitively, I guess I could have thought of it like that 9 grams is definitely not even going to be half of 26.982. So I just have to divide 9 by 26.982 to figure out exactly what fraction of a mole this is. But again, thinking of it intuitively is sometimes a little bit harder. And while it is better for your brain to problem solve and go through that process and you'll understand it better, I do understand that it might be easier to just have a process that is a surefire, quick way of getting an answer. So dimensional analysis can sometimes be that for students. So this last one is an example, but I'd like you to attempt it before I show you how to do it. So go ahead and pause the video, and after you've attempted, unpause the video to check that you've done it right. All right, I'm going to assume that if you're watching this, that you've already attempted this last example, so I'm going to work on it as a way for you to check to see how you did. So 3.6 moles of oxygen are consumed during the combustion of magnesium. How many grams of oxygen are consumed? So first things first, I'm going to figure out what's my conversion factor, which is just my molar mass of oxygen. Now, oxygen is a special element. It's a lot like bromine. Oxygen is one of our special 7 diatomic elements. It's a part of Brinkelhoff. Remember, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine are the 7 diatomic elements on the periodic table. What diatomic means is that their molecules are made of 2 atoms. So the molar mass of these diatomic elements is actually double their atomic weight. So oxygen's mass, atomic mass, is 15.9999. So its molar mass would be double 15.9999. And when I do this, gosh, I want to do it in my head so bad and round, but you know what? I'll just type in my calculator. I think it's going to be like just about 32, but maybe a little less. Yeah, 31.998. So I'll stick to the exact values. So the molar mass of oxygen, because it's diatomic, is 31.998 grams per mole. So this means 1 mole of oxygen, O2, because it's diatomic, is equal to 31.998 grams. So if I've got 3.6 moles of oxygen, that means I've got 3.6 times as much mass. So I could just do this in my head and do 31.998 times 3.6, and that would be a good way of getting the answer quickly if I'm confident doing it that way. But if not, I'm not sure that that's how it would work. I could always set this up with dimensional analysis. So 3.6 moles times a fraction. I need my moles to cancel out, and I'm trying to get to grams. And according to my conversion factor, 1 mole of oxygen is equal to 31.998 grams. My moles cancel out, and yeah, I'm going to end up doing the same thing, 3.6 times 31.998. When I do that, let's see what we get. 115.1928. That's not too many decimals to write, so I think I'll write all of them. 115 point, gosh, I forgot what it was already. 1928 grams of oxygen. So if I had to guess, if you made a mistake and maybe you didn't get this, if I had to guess what that mistake was, it was probably forgetting that oxygen is diatomic. So the sooner that you can remember Professor Brinkelhoff, the sooner it's going to be that you will maybe avoid making mistakes where you miss that an element that you're working with is diatomic. So that concludes our lesson. This is kind of a skill that we've been using for a while now, doing unit conversions. We're just now starting to do unit conversions with moles and grams, which is new topics that we learned yesterday. So go ahead and move on to your line practice and get really strong with this skill of converting moles to grams and vice versa.